Hi, John here. In this video, we're going to look at an oil filter. Specifically, we're going to look at the oil filter used on an internal combustion engine. I'm going to explain to you how it works, and then we're going to talk about why we have the oil filter in the first place. So we can see an internal combustion engine here. It's operating, and if we go down, we can actually see on the side that we have an oil filter. The oil filter is this cylindrical object mounted onto the side of the engine, and the oil will flow in and out of the oil filter. So let's now have a look at an oil filter, and I'll explain to you how it works. So here is our oil filter. You can see it's been removed from the engine, or perhaps it's been taken out of the packaging. And if we take a cross section, we can also see the internals. Now notice, if we spin this way again, this is the side that mounts onto the engine. This is actually a spin-on type filter. There's a screw thread in this section here, and the screw thread allows us to screw directly onto the engine and then tighten the filter up onto the engine. What will happen then is the oil from the oil pump will be distributed through these outer holes. There is 1, 2, 3, 4, 5, 6, 7, 8 of them, and the oil will enter through those holes and into the filter. The oil outlet is actually the center hole, this hole in the middle. So let's have a look also at the O-ring, because as we screw it onto the engine, obviously we don't want metal just seating on metal because we'll get oil leaks, and in order to get around this problem, we have an O-ring. The O-ring is this black piece around the outside, and that will be a piece of rubber or some sort of elastomer so that we can really squeeze that against the engine and get a good seal. So that will stop our oil filter from leaking. Got the outer casing of the oil filter. It's going to be metal. Take the cross section now. We'll go in. And we can see that the oil is going to come in through the hole on the right hand side, and it's going to meet this black piece as soon as it enters the filter. This is actually an anti-drain valve. You can think of it as being similar to a non-return valve. The oil pressure is going to push against the anti-drain valve, this black rubber type flexible material, and the oil is going to cause the black rubber piece to extend out to about here. So it's going to move across this way, and the oil will be allowed to flow in to the oil filter. So it's a type of non-return valve, but they call it an anti-drain valve. The anti-drain valve actually stops the oil from exiting the filter when the oil pump is switched off. So in other words, if we shut down the engine, the tendency is that the oil, due to gravity, is going to all accumulate in the oil sump at the bottom of the engine. However, with the anti-drain valve, what we can actually do is seal the oil in the filter, and that means that the oil filter is going to be charged or full of oil, and that means when we start the engine we're going to have a supply of oil already. If we were to drain the oil filter down, then we risk starving the engine of oil, and we may run the engine without any lubrication oil when we initially start it, and this is not good. We're going to get a lot of wear on the components. So that's the reason we have the anti-drain valve, and the oil will come in, it will flow around this way, and then it's going to come into contact with our paper pleats. These are these orangey brown paper pleats here, and the oil is going to flow through the paper pleats and into the middle. You can see that each one of these pleats is shaped a little bit like a flower, and the interior is hollow, and that's because the oil comes along. Just angle this correctly. It's going to come in here and it's going to pass through the paper and then down this way and pass through the paper again and into this central pipe here with loads of holes. The holes are all there to help the oil drain back into the center. So it's passed through the paper pleats, and now the oil can be referred to as clean, because when it passed through these pleats, what actually happened was that the impurities and the foreign bodies, which might be dust, dirt, rust, anything like that, they will become entrained upon the pleats and they'll be effectively stuck on the outside. The oil will pass through, but the impurities or the foreign bodies will not. So that's how we clean the oil. And once the oil has been cleaned, it passes through the central pipe and will go to our oil galleries, and then it will be distributed to the components of the engine. So that's what the oil filter is doing. It's keeping the oil clean. So now we know how it works, let's think why we would have an oil filter in the first place. Well, the main reason is to remove the foreign bodies and impurities, and this stops erosion of our engine components occurring. Let's imagine for a moment that we did not remove these particles, and these are usually quite hard particles. They feel very sandy when you rub them between your fingers and thumb. Now, if we didn't remove these sandy particles, these foreign bodies, then they're going to go straight to our bearings and other machinery components, and these components usually operate on very fine tolerances. Remember, a plain bearing has an oil film, and these bearings are also called thin film bearings. They're referring to the very thin layer of oil that separates the bearing from the pieces it's sandwiched between. So let's imagine that the bearing is sitting between the crankshaft and the conrod. Well, if we get a particle flowing through the oil system and it then flows and goes between our bearing, then we're going to scratch a piece of metal away from the bearing. Now, this scratching motion is called erosion, and the most likely piece that's going to become eroded is actually the bearing itself. Plain bearings are manufactured from a soft material. This is a material referred to as white metal or Babbitt metal, and it's very soft. So our sandy particles, if they get in there, they're going to scratch away at the bearing, and then we might end up with bearing hotspots, or we might just end up with a thinner bearing over time. And this might cause lubrication issues. So there's a lot of things that could occur if we start eroding away some of the engine components. So the oil system is absolutely critical to the engine. It cools the engine and it lubricates the engine. If we start having a very dirty oil system, then we're going to start getting a lot of problems. So that's why we have the oil filter. It's very simple, but you will need to change it periodically as it becomes dirty. But if you check in your engine manual, you'll soon discover that there are several ways when you will know to change an oil filter. The first way is using a measurement of distance, such as kilometers or miles. You may see in the manual it says after the first 5,000 miles or 5,000 kilometers or whatever the number may be. The next way is based upon service hours. For example, after the first 2,000 operational hours, in other words, 2,000 hours when the engine was running, or for example, after 4,000 hours, 8,000 hours, etc. And finally, if none of those are relevant, then there will be a note in the manual saying that the filter should be changed every 12 months as a minimum. So there are 3 different ways there of knowing when the oil filter should be changed. If you're working on a larger engine, you can just measure the differential pressure across the oil filter, and when the differential oil pressure becomes too great, you'll know that it's time to change the oil filter. A word of warning, if you change the filter too late, you may effectively starve the engine of oil because the oil cannot pass through the filter quick enough to get to the engine components. And what you'll notice is either that the engine will become quite hot and your lubrication oil temperature will also become quite hot. And you may also find that next time you change the filter, there are a lot more particles in there than there should be. And this is because the engine was damaged as it was starved of oil and didn't have enough lubrication. So you've not only had hot oil in the engine, but you've also damaged the engine due to the lack of lubrication. Should also mention as well that if there's a lack of oil, you're also going to have a lack of cooling, and you may also end up thermally damaging the engine. So oil, very, very important, and it's important that you keep your oil filter maintained in order that your entire oil system remains healthy and that your engine remains healthy. If you liked this video, please do share it on social media. It really does help us out and helps us produce more and more content. If you want to learn more about the combustion engine generally, the lubrication oil system, the cooling system, and how 2- and 4-stroke engines work, then check out the link in the video description below. And if you click on that link, you'll be able to purchase the course at a discount price. Thanks very much for your time.